Hi students. This section is about the practical task. Here we will discuss an application of classifying the iris species. These are the species of flowers, and we will use the machine learning algorithm to classify uh, these species. In this section, we will go through a simple machine learning algorithm and create a model. So we will introduce the core concepts and the terms of the machine learning. So let's assume an example. There is a hobby botanist and she is interested in distinguishing the species of some iris flowers that she has found. So she has collected the flowers and take a measurements associated with each iris. For example, the length and the width of petals, the length and width of sepal, and all measured in these all measurements are in centimeters. She has the measurements of some iris that have been previously identified by an expert botanist belonging to three species. These species are Setosa, Veriscaler, and Virginica. These are the three classes for the machine learning. For these measurements, she can be certain of which species each iris belongs to. Let's assume that these are the only species one hobby botanist will encounter in the world. Our goal is to build a machine learning model that can learn from the measurements of these irises, whose species is known, and so that we can predict the species for new iris. So because we have measurements for each, for which we know the correct species of the iris, this is a supervised learning problem because we already know the labels or the species for each measurement. In this problem, we will want to predict one of several options. This is an example of classification or classification problem. The possible outputs are called as classes. Every iris in the dataset belongs to one of the three classes. So this problem is a three-class classification problem. The desired output for a single data point is the species of the flower. For a particular data point, the species it belongs to is called the label. The particular data point the species belongs to is called the label. So first of all, we will load the data. The data we will use for this example is a iris dataset, a dataset in the machine learning and statistics. And this dataset is also included in the scikit-learn library, Python library, and it can be downloaded as well. So for this first part of the code is from sklearn dataset, we will download the iris dataset. So this is the first part of the code. So it is the downloading the dataset. So it has downloaded the dataset and has been loaded as an object as a dictionary. It contains the keys and the values. So next part of we will see that what are the keys for this dataset and the values for this dataset. So the keys of the iris datasets are the data, target name, description, feature names, and file name. The value of key description is a short description of the dataset. We will show the beginning of the description here. So let's run this command and we will see that it shows the description of the iris dataset. Iris plant dataset and dataset characteristics. It contains 150 instances and it contains the number of attributes and 50 classes of 50 in each of the three classes. So then it comes the value of the key target names is an array of string containing the species of the flowers that we want to predict. So we are going to see the three target classes. And what are the three target classes? We run this command and see that three target classes are the Setosa, Veriscaler, and Virginica. Next, the value of feature name is a list of strings giving the description of each feature. So then we are going to see that what the each feature is. So feature names and what about the each feature is. So this command will give the each feature. The first feature is the sepal length, the second is sepal width, third is petal length, fourth is petal width. So the data itself is contained in the target and data fields. Data contains the numerical measurement of sepal length, sepal width, petal length, and petal width in NumPy array. So then we print the type of the data set, the what type of data set. This data set is a NumPy array, is a NumPy, is in the form of a NumPy array. So the rows in the data set corresponds to the flowers, while the column they represents the measurements that were taken for each flower. So we will going to see the shape of the data set. What is the shape of the data set? What are the rows and what are the columns? How many rows and how many columns are in the data set? So we will see that shape of the data set is there are 150 rows, 150 flowers have been observed, and for each flower we have the sepal length, sepal width, petal length, and petal width. We see that the array contains measurements of 150 different flowers, and the individual sample in machine learning and properties are called the features. So individual items are called as samples, and the properties are called as features. So the shape of the data is in NumPy array. So then here we are going to see for this is convention in scikit-learn, your data will always be assumed to be in this shape. Here are the features of the first 5 samples. So we're going to take the features of first 5 samples. So we run this part of code and see the features of first 5 samples, first 5 flowers. So we can see that the first 5 flowers, the petal width is 0.2 centimeter for all of them, but for the first flower has the longest sepal length 5.1. The target contains so these are the 4 features for each flower or samples or instances. The target array contains the species for each of the flower that were measured, also as the NumPy array. So it is so we will see that what are the target and what is the shape of the target. So we will see that the shape of the target is a NumPy array as well. So target is one-dimensional array with one entry per flower. So we will now we are going first we check the class of the output and then we target and then we check the shape of the target. So the shape of target is a is is an array one dimensional array of one for 150 different instances. This species are encoded as integer from 0 to 2. Then we are going to see that the species how the what is the shape of the species, how we represented the target. So species are in the shape of integers, integer from 0 to 1. In class 0 is 0 means it belongs to the class Setosa. 1 means it belongs to the class Veriscalar, and 2 means that it belongs to the class Virginica. Then it comes the training and the testing of the data set. We want to build a machine learning model from this data that can predict the species of the iris for a new set of measurements. But before we move, we apply our model to new measurement. We need to know that it actually works. That is whether we should trust the data or not. So we will apply some statistical analysis on it. Unfortunately, we cannot use the data we use to build our model. This is because our model can always simply measure all the training set, while other always predict the correct label for any of the point in the test set. The remembering does not indicate to us whether our model will generalize well or not. To assess the model's performance, we show it new data for which we have labeled. This is usually done by separating the data we have collected. Here we have the 150 flower measurements. into two parts. We will divide it. One part is built for the training purpose as the training data, and the other part will be the test data or the test set. Scikit-learn contains the function that shuffles the data and separates for you using the train test split function. This function manages 75% of the data to the training set and 25% of the data to the test set. In scikit-learn, data is usually denoted as a capital letter X, while the label is denoted as a lowercase y. This is inspired by the standard formulation in mathematics, where f of x is equal to y, where x is the input to a function and y is the output. Following more conventions from mathematics, we use capital X because data is a two-dimensional array matrix, or a lower dimensional Y because the target is a one-dimensional array Y. We call the train test split into on our data and assign the outputs using this nomenclature. So we will apply the from the scikit-learn we import the scikit-learn we import the function train test split, and using the train test split we divide the data into data and the target into training and test data. So we are going to divide the data into we're separating the data into train data and test data, x train, x test, y train, and y test. Before making the split, the train split function shuffles the data using a pseudo random generator. If we just look the last 25% of the data as test, all the data points would have the label 2. The main thing is that this split function, it fairly shuffles the data, then it separates up so that all the classes are in the test set, all the classes are in the test training set. To make sure that what we get the same output, run the same function several times and provide the okay. So output of the training test split is x train, x test, y train, and y test, which are all numpy arrays. X train contains 75% of the rows of the data, and X test contains the 25%. So we run this part of the code and check that how it looks like. So printing the training data. X train, it contains the training data, and Y train, it contains the outputs for the training data, and X test, it contains the test data, and Y test, it contains the target for the test data. So now look at your data. Now we look at the data. Before building a machine learning model, it is often good idea to inspect the data. So if there is some ambiguities or some discrepancies or abnormalities in the data, maybe some of the iris measurements are in centimeters or some are in inches. If this happens, we check that. So one way, best way to inspect the data is to visualize it. One way to do is by using a scatter plot. A scatter plot of data puts one feature along the x-axis and other feature along the y-axis, and draws a dot product of each point. Unfortunately, computer can only show the 2D plot. One way around this problem is to do a plot, and here we do this, and for this we draw this. We need the library mglearn. So we run this code, and it has successfully installed. Figure below is a pair plot of features in the training set. The data points are colored according to the species the iris belongs to. To create the screen plot, first convert the numpy into pandas print, and pandas has a function to create pair plots called scatter plot. So I'm going to close this one and now then run it. So we have made the pair plots for all the features. So first we have drawn the 4 features as the row wise and the column wise: sepal length, sepal width, petal length, and petal width. Sepal length, sepal width, petal length, and petal width. So this is the column are the histograms, whereas the other are the are the scatter plots. So we can see these scatter plots that there are the three classes, and by using some function, some classifier, we can classify these three classes. So it is these three classes are separable if we can use some machine learning algorithm in a better way. So these plots see that three classes seems to be relatively separated using the SQL and PTL measurements. This means that the machine learning model will likely be able to learn to separate them. So building the first KNS model, we start building the actual machine learning model. There are many classification algorithms in scikit-learn that we should use. How we use the k-nearest neighbor classifier is which is easy to understand. Building this model consists of storing the training set. To make a prediction for a new data point, the training set, the points in the training set matches that to which it closely follows. Then it assigns the label of the training set to the new data. So k in the k nearest neighbor signifies, instead of using only the closest neighbor to the new data, we can consider any number of k neighbors in the training set. We will discuss this in the lecture in detail. Then we make a prediction using the majority class among these neighbors. Our machine learning models in scikit-learn are implemented in their own classes, which are called estimator class. The k nearest neighbor algorithm is implemented as a k neighbors class. This is all the functions in the Python. They are implemented as a class, data structure class. Before we can use the model, we need to instantiate the class into an object. We need to instantiate the class into an object. This is because this is when we set any parameters of the model. The most important parameters of k nearest neighbors classifier is the number of neighbors, which we will set to 1. So we import the class from sklearn, and then for our case, we set the neighbors is equal to 1 and check that how it makes a prediction. So then we fit this model on our training data. So I run this part of the code, and now the algorithm has k nearest neighbor has learned on the training data, and now we make the prediction. We make a prediction using this model on new data for which we might not know the correct labels. Imagine we found an iris in the width with a sepal length of 5 centimeter, petal width of 2.9 centimeter, petal length of 1 centimeter, and petal width of 2 centimeter. So then we are going to find the label for this measurement. So we put this data as a numpy array here as a numpy array and check the measurements for this. And this is the shape of the input data. Note that we made the measurements of the single floor into a row in a two-dimensional NumPy array, and scikit-learn always expects two-dimensional array of the data. So here we are going to make the prediction, and we see. So here we made the prediction and find that the prediction is 0. It means that the target class is setosa. These measurement or the sample, it belongs to the class setosa. Then it comes evaluating the model. This is where test set that we have created, it comes. The test set data was not used to building the model. And we do know that the correct species for this iris in the test data. So we put this test data to our k nearest neighbor and try to find out the labels for all predictions. So I run this part of the code and see that these are the predictions. And we also have the actual prediction as a y test, and we compare them, the y predictions, predicted label and the actual label, and see that what is the what percentage of correct labels we get. We get the 97% of the correct labels. So we can run this prediction as a test score as well, test score function as well. So this is the 97% of the time. So this means that the test accuracy of our model is 97%. So summarizing this on this practice lecture, we do that. We started with a brief introduction on machine learning and its application, discussing the distinction between supervised and unsupervised learning. Then we formulated the task of prediction which species of a particular data flock belongs to by physical measurements of the flock. We used a dataset of measurement that was annotated by an expert with correct labels to build a model, making this a supervised learning task. This was three possible species, Setosa, Veriscula, and Virginica, which made the task as a three-class classification problem. The possible species are called as a class in the classification problem, and the species of a single iris is called label. Species. The iris dataset consists of two numpy array, one containing the data and which is X in scikit-learn, and one containing the correct desired labels, which is called Y. The array Y is a two-dimensional array of features. The array X is a two-dimensional array of features with one row per data point and one column per feature. The array Y is a one-dimensional array which contains one class as a label, integer value from 0 to 2 in our case. We split the dataset into training and test set and find that and evaluate that how better generalize our model on the test set or unseen data. We choose the k-nearest neighbor classification algorithm, which makes the prediction of new data by considering closest neighbors. This is implemented as a k-nearest classifier class in the Python. We build the model by calling it the fit method, fit function, passing the training data to it, and finding the score during the evaluation. And we find that 97% of the times our model correctly classifies the test data and has a 97% accuracy. This gives us the confidence to apply the model to new data and trust that the model can correct about 97% of the time. This is a summary of the code. So this is the test score about 97%. So this snip contains the core code for applying the machine learning algorithm using Scikit. So thank you very much. Thanks for watching. Thank you.